All right, so today we're going to talk about the materials and kind of what different materials are and some of the benefits and drawbacks. And then on Thursday, we'll talk about some of the properties of those materials. So Thursday we'll talk about some of the physical properties, chemical properties, what makes a material. But today I'll be just kind of what the materials are, kind of different ways you can see the material, different forms they come in, and stuff like that. So anything here look interesting? This is kind of the whole gambit.
Is that rock?
This?
That basket, is it rock?
No. It's little brass balls stuck together. And they're put together. That's a process called sintering. So they have them, and this is kind of a big scale version. Usually when you sinter stuff, it's like real small powders. But they have that, and then they actually heat up enough that they actually melt into each other and stay that way. So we've got, what's that?
Whirlpool?
Yeah, stainless steel probably.
Oh, yeah.
What's that?
Plastic.
Plastic.
Aluminum.
Aluminum. And just by telling, you can see the difference between the stainless and the aluminum, right? What's that? Just what is that in general? Does anyone know what that is?
Alloy?
No. Just look at these pieces here. What are those pieces? What's it look like the part is? Can't tell. No. It's the suspension on an F1 car. So here's, you can't really, there's not really much. The tires here, the chassis there. But what's that made out of? You want to know?
Titanium?
Aluminum? No.
Carbon fiber?
Carbon fiber. It's all carbon fiber. We got
What's
good
carbon
old
fiber?
What?
Carbon fiber. What's that?
What's carbon fiber?
It's
Woven carbon.
whole bunch of fibers.
I heard of fiber
it's a
mesh.
fiber
We do
cloth,
concrete.
yeah.
We
It's
do
like
fiber mesh.
fiberglass, but it's carbon fibers instead of glass fibers. So carbon stuff that's in your pencil, it's really strong.
So they make that out of mesh.
Uh-huh.
Because we do concrete. We do there's a fiber mesh.
Yeah.
You pour it into concrete.
Yeah.
Pour it
So
like
we'll
that.
talk about that. Good old wood, just plain old wood, right? And then here we've got an engineered wood. Really bad picture. But now we've got different layers of wood, different ways, so it behave differently. What's that?
Brass.
Brass. Some ceramic stuff. And then fiberglass. So that's basically kind of the different things, materials we're going to talk about. So let's start with wood. The good old-fashioned wood, forever.
Yeah.
So wood's used a lot in construction. Right? Where is wood used in manufacturing?
Dining tables.
Yeah, tables, furniture. So like these tabletops.
a lot of tools have wood in them.
Yeah, tools have wood components.
Paper, cardboard.
Yeah, wood products, so paper, cardboard, pulp products. So let's look at. So what's that?
Laminate.
No.
Veneer.
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 So veneer is like a thin shaving of the wood. So laminate, what you said, that's something that also looks like wood to cover something. So veneer. So when would you use a veneer? What's the benefit of that?
It covers wood, the rough wood.
Yeah, if you had some rough wood, or some cheap wood, you could put a veneer on it to make it look better. Or you could take the veneer and cover
Plywood
that.
or sheeting.
What's that? Yeah, plywood, right? So plywood is layers of a veneer. So veneers can be really thin or thicker. Plywood is layers of it. What's the benefit of plywood over solid wood?
It's stronger and it's cheaper.
Cheaper, stronger. Why is it cheaper and stronger?
stronger because of the layers. It's cheaper because you don't need a huge solid chunk of wood. You can make it smaller.
Yeah, you get a lot of, you shave down a log, you layer those pieces on top, and then you don't have to buy. You can find a piece of wood that's good quality all the way through. Strong, because the layers. And what about the layers?
They go in different ways.
They're going different ways, right? So now it's not weak in one spot. What's a drawback with plywood? Yeah, some people don't like the look of it.
It's probably weaker against moisture.
Yeah, there's, depending on what they use to put it together, it could be a lot weaker to moisture because now they've got glue in here that the moisture can attack. It's not just solid chunk. So the benefits and drawbacks. And you can also, from that, make things like that. So wooden I-beam. So instead of getting a 4x8 or a 4x10, you put one of these in. It holds a lot more weight, and it's a lot cheaper, and it weighs less. So kind of by taking the different things, put them together. What's a real good benefit of wood in general?
Structure.
Yeah, it's pretty cheap, it's easy to get. What else?
Abundant.
Yeah, it's abundant. It's all over. What else?
Easier to work with.
And easy to work with. You can work with wood with anything, right? If you've got a knife with you, you can work with wood.
Wood's
If you're whittling.
isn't a wooden building more repairable after a fire than a metal building? Its metal will warp all the way through.
Yeah, it can be. Whatever. Depends on how it was. So it's easier to work with. If something gets bad, you can easily cut out a piece, put something else in. What else? There's some other benefits of wood. What?
Oh, I don't know whether
It's
there's
light?
benefits we said.
Yeah, it's relatively light, right? What else?
It's easily refined.
Yeah, you can, yeah, we're saying that, so you can easily work with it. So, what are some other drawbacks of wood in general?
Drawbacks.
Yeah, it's flammable. It can burn pretty easily. What else? What do you say,
Water
Robert?
affects it.
Yeah, water, so moisture really affects it a lot, right? What does wood do when it gets wet?
Swells up.
Swells up, changes size,
Rots.
but it rots. Insects like to eat it. Lots of things like to eat wood. So, yeah, any other comments on wood? All right, so then we go to ferrous metals. What does ferrous mean?
Iron? No, it's
Yeah, it has iron in it. The ferrous means iron. So the ferrous metals are all the metals that have iron in them. And this is kind of its own category, and then we have the non-ferrous metals we'll talk about after. So we have iron. And then from iron, what do we do to it to make other kinds of ferrous metals?
They have stuff too.
We add stuff to it. What's that called? Now we can make steel, which is something else, but what is it called when we add stuff to iron to get something else? So we can add some carbon to it. We can add some tin, some magnesium. What's that called? What?
Fusion.
No.
No.
No. What are the different types of steels called? Again, it starts with an A. An alloy.
Oh, yes, right.
So you take iron, and you add alloys, or you add other materials to it to make an alloy. So if you add carbon to iron, what do you get?
Steel.
Steel. So, and then what does the carbon do to the iron?
Strengthen it.
Yeah, it makes it stronger. So just iron by itself it's not real strong. It's pretty strong, but it's not as strong as steel. What else? What other alloys can you make? What else can you add to steel? What? Again.
Zinc.
What?
Zinc.
Yeah, you can add zinc, chromium, tin. So you can get chromoly. So like chassis are made out of chromoly steel, bikes, dune buggies, stuff like that. You can add other things. You get stainless steel, right? So what's the benefit of stainless steel?
It won't rust.
It doesn't rust, and that's a big drawback of regular steel, right? And iron. They rust. What's rust called? What makes rust?
Corrosion.
Oxygen. So rust is iron oxide. It's a combination of iron atoms and the oxygen. And in steel, the rust, you can really see, right? It changes from a nice gray color to a nice bright orange color. What does the rust do to it? Corrodes it, takes it off, it gets weak. So stainless, by adding other elements in, now you don't see that. It fights off the corrosion. What else can you do to steel to fight corrosion? Galvanize it. So what's galvanizing do?
Dipping in zinc.
Yeah, dip in zinc. Now you've got a nice coating on it that doesn't corrode as much. What are some benefits of steel? Of all steels? Yeah, they're really strong. And depending on how you treat them, they can be somewhat flexible or not flexible, or they can be really strong or really brittle. So depending on how you treat them, it really has a large variation of different alloys, different treatments on what it's going to behave like. What else?
It could be used in like long lengths.
Yeah, you can make it big pieces, you can make it small pieces. What else? That's another good benefit of steel.
Lasts a long time.
Yeah, it lasts a pretty long time if it's taken care of, right? If you take care of it correctly, it'll last forever, almost, until you stop taking care of it. Anything else? Any other comments about steel? So the non-ferrous metals. What are these? Aluminum. So what's the benefit of aluminum?
It's light.
It's light. How light? Compared to steel.
Half.
No. It's about a third of the weight. And it's about half the strength. So there's the trade-off is favorable. You don't lose as much strength as you lose in weight. What else?
It's recyclable.
Yeah, it's easy to recycle. Is the raw material as abundant? No. So because, remember, in iron, can you just find iron in the ground? Yeah. You just find big piles of iron, dig it up, melt it, use it. Remember, we watched last week the video on aluminum, and you can't find just chunks of aluminum in the ground.
You gotta make it.
It's in with other things, and so you have to separate it out. So to get aluminum in the first place is real expensive. Takes a lot of work. But then once you have it as aluminum, it's easy to recycle and make new stuff. You don't really lose much in the process, and it's a lot more efficient than getting new aluminum. What are some other benefits of aluminum?
It's non-corrosive.
Yeah, it's not corrosive. Does it rust?
No.
Okay. It doesn't make iron oxide, but it makes aluminum oxide,
Yeah.
which is rust. But aluminum oxide is clear, and it's not as corrosive as iron oxide. So you don't see it, so it doesn't affect the appearance. So are there other ways to make it so that it doesn't make aluminum oxide? Yeah, you can anodize it, so you can actually change the surface composition. Oh, anyone weld in here? I know there's a couple welders. What do you have to do before you weld on aluminum?
Clean it physically.
You have to clean it, right? So that's taking off that aluminum oxide layer. And so it rusts really quick, but you can't see it. It's kind of, that rust layer protects it from other corrosion. What are some other non-ferrous metals?
Brass,
Yeah, brass,
bronze,
bronze. What are brass and bronze? What's the difference between brass and bronze? What do they both start with? What? They both start with copper, right? And then you get brass, and bronze from that. What's the difference? Yeah, one has zinc, one has tin. Which one? Yeah, brass is tin, bronze is zinc. That's one that I always forget too. But they both start copper. So, which one do we use more in manufacturing stuff?
What is brass?
Yeah, brass. Bronze is more what?
Expensive.
More expensive, more artistic kind of stuff they do with bronze. For manufacturing use, we use brass for things. What's a benefit of copper? Yeah, it's really good at conducting electricity, right?
Yep.
Anything else really good at conducting electricity?
Gold.
Gold. Notice anything? It's gold.
Wow.
I'm trying to think of the symbol for gold. So, copper and gold. No, Ag is silver. Is it? I'm not a chemist. I don't have it memorized anymore. So, copper and gold. Really good at conducting electricity. What about aluminum? Is aluminum good at conducting electricity? Yeah. You go out and buy electrical wire. You can buy aluminum Romex for the walls. So, non-ferrous metals, really good at conducting electricity. The better ones, what do they have in common? And they're expensive. Go look at copper and gold. What do they have in common?
Color?
They're both yellow, right? The yellow metals. Yellow marker. Coincidence?
No.
I don't think so. What are some of the drawbacks of the non-ferrous metals?
Very pliable.
Yeah, they're a lot more flexible, not as strong. Are there any other non-ferrous metals besides aluminum, copper, and gold? Lead. What's a good benefit of lead? It's heavy. It's pretty easy to work with. What?
Soft.
It's soft. What's a big drawback of lead?
Soft.
It's soft. It's heavy. It's poisonous. What about other ones?
Drawbacks?
No, other non-ferrous metals.
Oh,
Zinc and tape over.
Silver. What else?
platinum?
What?
Platinum?
Platinum. What else? You said one earlier.
Titanium?
Titanium. What's really good about titanium?
It's
It's
light
really
strength.
strong and it's really light. What's a drawback of titanium?
Really expensive.
It's really expensive, really hard to work with.
Wears out fast.
What else?
Beryllium.
Beryllium.
Kryptonite.
What else? Oh, I heard magnesium.
Nickel. Magnesium.
Well, so what's really good about magnesium?
Really light, really strong.
Really light, really strong. It's a drawback of magnesium.
Flammable.
It's flammable just in the open atmosphere. It ignites really low and burns really hot. Yeah. And once you get it going, it makes its own oxygen. It goes. So any other non-ferrous metals?
Nickel.
What?
Nickel.
Nickel. Anything else? What's nickel used for a lot? Plating. So before you chrome plate something, usually you'll nickel plate it to give the chrome something better to hold on to. Then we get to plastics. What are the two main types of plastics? Does anyone know? Was it in the book? What are the two main types of plastics? Give you a hint, they both start with thermo. We have thermoplastics.
Thermoset.
We have thermoplastics. What do you think that means? Well, let's just look at the word plastic. What does the word plastic mean? Not the material plastic. What does the word plastic mean? So they had the word before they had the material. No. No.
Capable of being shaped and molded.
Yeah. So you can change the shape. You can mold it. You can bend it. That's what the word plastic means. So what does thermoplastic mean? What does thermo mean? Heat, temperature.
Plastics are something that's formed with heat.
Yeah, it's plastics that you can reshape when you heat them up. So the thermoplastic, you get it, you can melt it, reshape it, melt it again, reshape it, melt it, reshape it, like that. Then we also have another kind that's called a thermoset.
You need to put polymers on there?
What?
Or just thermoset?
Thermoset. So most plastic materials are also polymers. So polymer is kind of a man-made material or a chain of things. Instead of just being atoms by themselves, it's a chain of atoms linked together. So if thermoplastics mean you can melt them and reuse them, what does thermoset mean?
Can't hold their shape.
Heat doesn't affect them. So like this guy here, you put a lighter on it, it might melt, but you're not going to be able to reshape that and use it again. Also, thermoset's probably a lot harder than the thermoplastic. They feel different. Where do we get plastics? So how do we make the polymers that go into plastics?
Don't we take it up? Oil.
From oil. So usually hydrocarbon oil. So they pull out the polymers when they're refining the gas. In part of gas refinement is gasoline, diesel, and heavy oil. And they also pull out polymers that they use to make plastics. Also, you can make them from other oils, like vegetable oils. Now, they're starting to do that. So vegetable oil ones, guess what? Recyclable, or biodegradable. So, what are some benefits of plastics?
It's recyclable.
And most of them are recyclable. Especially the thermoplastics, right? Thermoplastics, melt them down, reuse them, you recycle them. Thermosets, not so much. What else? What's another benefit of plastic?
Cheap.
Yeah, they're cheap.
Easily molded.
Yeah, you can mold them easily. You get them into all different shapes. What else? Yeah, they don't corrode. A lot of them don't react with things. What else? they're pretty tough.
Temperature.
You can take plastic and you can do it. It'll bend it, but it'll hold. It'll come back to its shape. What else?
Pretty resistant to heat.
Yeah, they're resistant to heat up to a point, right? Depending on what their melting point is. Some of them you can heat all the way up. They don't do anything. Some you just put a little lighter under and they melt. So it depends on what type of plastic it is. What else? Yeah, they last forever. That's also one of the drawbacks, right? They don't biodegrade. They don't corrode. What else? Okay, what are some drawbacks? What?
They did a study where the water ball set out in the sun. Because it's cool inside the water.
Yes, so they can have reactions with other things. So they had a big thing not to use a certain type of bottle for kids and stuff because some of the stuff might leak into the food. What else?
Well, drawbacks on.
Yeah.
Toxic. They're toxic when burned.
Yeah, if you burn them, they set off toxic fumes. So that goes in the waste, right? You can't put them in the trash and then they stay there forever. You can't burn them because they're toxic. What else?
They're not strong.
Yeah, they're not necessarily that strong. Depends on how you put it together, but yeah, for the most part, they're not strong. And that's because they're flexible and everything, but they are tough. So, what else? What are some types of plastics? PVC. What's PVC stand for? Polyvinyl chloride. It's got chlorine in it. That's what makes PVC really bad. What else?
UHMW.
UHMW. Anyone know what UHMW is?
Plastic.
What's UHMW stand for? Ultra high molecular weight. So it's a real dense plastic. And what about what else about UHMW?
It doesn't wear as easy.
Yeah, it doesn't wear out. It self lubricates because it's what?
It's not abrasive.
Yeah, it's not abrasive. So you can have UHMW. If you feel it, it feels oily, but it's not. Like you can feel it, you can slide around real easy. Take your hand off, and you have no oil residue at all. But so for pivots and for sliding things, it's really good. What else?
Flexing.
Flexing. Anything else? Polystyrene. So food containers. What's the real benefit of polystyrene? Yeah, it's insulative. What else? It's easy to make. What's the drawback? What? Yeah, 600 years. That's one that you can't. It doesn't. You can't reuse it. That's a thermoset. What happens when you get it hot? It just melts away, right? Melts into nothing, but sets off some pretty bad gases.
Well, like a bag of chips?
What?
Or what are you talking about?
Polystyrene, so like styrofoam cup.
Oh.
What else?
Polypropylene.
Polypropylene,
Caps. Urethane.
urethane. So that's some of the synthetic rubbers. Right. And also rubbers kind of fit into the same category.
What about nylon?
Nylon, yeah. Well, what's a clear one? What? No, Lexan. But what's the broader category that Lexan is in? Lexan's a brand name. Acrylic.
Acrylic.
So we have acrylics. All right. We need to know other things about plastics. So ceramics. What do you think about when you think ceramic?
Toilet.
Toilet.
Tile.
Tile. So what is a ceramic?
Inorganic non-metal.
What?
Inorganic non-metal.
Yeah, it's inorganic. So it's not from a plant or a person, and it's not a metal. So what else is it? What's the main inorganic thing in it? No?
Inorganic.
What? Clay. So it's clay, and then what do you do with it?
Cook it.
What?
Cook it.
Cook it. You heat it up, and the clay turns into what?
Solid.
Yeah, it turns into a ceramic. Depending on what's in the clay, what's in the mixture of sand and water. You can get glass also. Right? If you use just sand and not some of the other filler stuff, you get glass. What's some benefits of ceramics?
They retain heat.
Yeah, they're pretty good with heat, right? You can put ceramics on the bottom of the shuttle, and it comes in against all that heat, and something an inch away doesn't feel any heat. What else? What else is really good about ceramics?
It's not abrasive.
Yeah, they're not usually abrasive. It depends on how you finish the surface. And you could finish it where it's really abrasive, right? We can finish it where it's really smooth. What was that?
It resists abrasion.
Oh, it resists abrasion, yeah. Sorry. So it won't. You can't really chip it off. You can't take it off real easy. Take out big chunk or nothing. What else is a good thing about ceramic? Yeah, before you fire it, it's really easy to work with. What about after you fire it?
Brittle.
Really hard to work with. It's really brittle. But what's the benefit that comes with being brittle? Strong, right? You take some of that ceramic, and that thing is going to be really strong if you use it the right way. If you use it the wrong way, it's not strong. So like that. The orange things are ceramic. What do we call that usually when we put them there? What kind of a ceramic?
Is that a cutting tool?
Yeah.
Diamond?
No. Carbide. It's a carbide ceramic.
Carbide ceramic.
Cutting tool. And so these things, it's a ceramic, they're cast and they're ground. And so why use a ceramic as the cutting edge instead of the steel as the cutting edge?
It resists abrasion.
Yeah, it doesn't abrade, it stays sharp. If that gets worn out, what do? You take it out, turn it a quarter turn, put it back in. Now you're using that side instead of the bottom. And then you just they can last long time because you have multiple faces on them. What else about ceramics?
It doesn't burn.
Yeah, they don't burn,
It doesn't rust.
but they don't rust. So think that's pretty much got them. And their major downfall is what?
Brittle.
Aaron said already. They're real brittle. You hit them wrong, they just shatter. They don't just get a little bend. They just whoosh, gone. Then we have composites. So this is kind of a real big category with a lot of different stuff in it. What does a composite mean?
Multiple materials made up into one.
Yeah, composite is multiple things in one. So what are some composite materials?
Carbon fiber.
Yeah, carbon fibers. I don't have a picture of carbon fiber, but I have a picture of fiberglass, right? Carbon fiber is the same thing, but instead of being glass fibers, it's carbon fibers. So you have a mat of material, and then you put what with it?
Resin.
A resin. So this provides some of the strength, provides the longitudinal strength, and the structure, and then the resin provides the strength to hold it all together. You just use one layer if you're doing a composite with fiberglass or carbon fiber. No, you use multiple layers. Do all the layers have to be the same? No, because you could do a layer of fiberglass, a layer of carbon fiber, a layer of aluminum, another layer of fiberglass, a layer of wood. You can build it up using any mix of the layers you want. Does it have to be in a sheet like this? No, you can have it where it comes out just little fibers and they go all different directions when you put them down. Instead of being here where they're all linked together. What else? Well, what's the benefit of carbon or of fiberglass and carbon fiber?
It's light and strong.
Yeah, it's light. It's really strong because glass is really strong. But now, because they're little tiny pieces of glass, we don't have to worry about it shattering. If one little tiny piece shatters, you've still got 1,000 other pieces there. Carbon is not going to shatter until you get to really, really bending it. So it's really strong once you've made it. It's really light. What else? What are other benefits of fiberglass, carbon fiber?
You can shape it, whatever way you want.
Yeah, it's really easy to shape. You can put it over a mold, you can wrap it around something, you can really push it in, and get it exactly like you want it. Anything else about carbon fiber, fiberglass? It's pretty much the same process used to make both of them, just which material you put in. What are some other composites?
Cardboard. Wood.
It could, yeah, wood. Cardboard could be, but wood. Wood is a composite, right? You got wood fibers and then lignin holding it together. So any wood product is basically a composite, but usually we'll just call it wood. What else? So in wood, there's some other engineered products in wood. We were talking about plywood. What are some other engineered wood products that are composites?
Blue lamps.
Particle board.
Yeah, particle board.
Sheathing.
So MDF is the name that's used for it. Medium density fiberboard is one that's common. They have low density, which really doesn't have any strength or anything. That's the crappy stuff. Then you have MDF, which is really used for a lot of things. It's good quality. It's got good strength. You laminate it to get a good product. What else? What's another?
OSB.
Yeah, OSB. So. Here, OSB. So now instead of just little pieces, you've got long pieces. And they can be put together so that it provides a lot of strength to it. Again, being held together with what? A glue. So fiberglass, we use a resin. For those, we're using a glue. Same basically, it's an adhesive, hold it together. What else? are some other composite materials?
Aluminum?
No?
Metallic.
What about metallic?
It's like that's a bunch of materials put together to make one solid.
So something like that? So it's called metal matrix. So they have ceramic brake pads. They also have metal matrix brake pads where you've got pieces of different types of metals, and they're not melted together to make an alloy. They're just stuck together and pressed and glued to hold them together. Or they might be heated and then sintered. So like I said at the beginning, with those little brass balls, you can get them all pressed in, heat it up so they kind of bond to each other. Or you can use an adhesive, so some kind of resin, or just the pressure hold together. So like a pill, right? So like a little pill tablet. There's no glue in there. They just press it really hard to get to make that shape. So they can do the same thing with metals. What else? Another type of composite.
Wood? Heavy wood?
Let's think fake wood. Composite decking, right?
Oh, composite, yeah.
Now you get the look of wood, but now it's a plastic and a resin being mixed together to get what you want. And you can have different shapes. So it's a benefit of that. Yeah. So in general, it doesn't rot like wood does. But why do that instead of that?
It was lighter.
Yeah, lighter. A lot of airspace in there instead of being solid. Is it as strong as this?
Probably. Probably stronger.
Probably as strong or stronger. And how do you know that? Just by looking at it. Just got how much empty space in it. If you got something with thin walls, what makes it strong? What was that? Yeah, so anytime that you've got a rib, that adds strength. So like in sheet metal, I'll come over, bend, bend, bend like that. Each time you bend 90 degrees, you add strength to it. So it might not look like that bend is doing anything, but it's adding strength to the whole thing. So they do the same thing here. Get some vertical supports in there, that adds a lot of strength to it. Okay. Questions? So is that all the materials are? What other things are there? Yeah, cement. So what would cement be? That's a composite, right?
Composite, yeah. You got mortar,
It's
sand.
in that category. It's got a couple different things. It's got some sand and some lime, and the cement itself. To make concrete, you use cement, sand, lime, some water, mix them together. What else? Any other good materials I missed?
What's asphalt made of?
Same thing. Tar, bits of rock, different sizes. What?
Adobe,
Oh, wait. That's clay. It's ceramic, right?
clay, porcelain, hay.
So we had said someone said porcelain earlier, right?
Yeah.
What was porcelain? It's a ceramic, and usually it's ceramic coating something else, right? So you put porcelain on top, so it's a type of ceramic. Usually we'll put porcelain on top of metal or something like that to give the metal a nice ceramic coating. Right. You can also have it just by itself. But what's good about porcelain? Between that and just like a standard ceramic. It's different.
Shiny.
Yeah. The sand in it is really small, the clay is really small. So you're really smooth, really shiny. You put in a real good glaze on it. So you do the ceramic, you put a glaze on the ceramic. And also porcelain will kind of turn into glass when you melt it. So it'll become shiny itself also. What else?
About porcelain?
What?
About porcelain?
Oh, about anything. Any other materials?
Oh, cardboard.
Cardboard, so we mentioned that already.
Really?
A long time ago when we were talking about wood and pulps. No. So, there's this website called inventables.com. And so this is where people put all the new types of materials that they're making. So like temperature sensitive things. Mineral wood, so it's wood that's infused with mineral oil and other things, so then it's fire retardant. So this is the website. So there are all kinds of actual products. You can actually go in and see components that are made using different types of materials put together. And then over here, under what? Yeah. You can buy those in Master. When you get to a specific torque, there's a thing on the head that changes color. You don't have to use a torque wrench. You just
They're extensions.
what?
I have ratchet extensions that do
Yeah.
that.
Yeah, it's the same thing. So it makes it so that it's kind of dumb-proof, right? You don't have to have someone set up the torque wrench, try calibrate the torque wrench. They put in 50 foot-pound rated bolt. They turn it till it turns red, and then okay, now it's right torque. I let go. But if we go to raw materials, we got all these, so you can go in. Say you want to look at sand and stone. So waterproof sand. What is that? Put it in, pull it out into the water, and it's perfectly dry. It's not like damp or anything. Some ceramic stuff. Foams. Some biodegradable styrofoam. Let's see, where's a good one? Composites. Translucent concrete. A thermoplastic and a wood blend. Rubberized plant fiber. They have, I haven't, not here, but they have the permeable, or the concrete that water can soak through. So changing existing materials to a way that's different. So lots of new type of materials engineering. That's a whole field of engineering in itself, just changing how the materials are used.